Greetings, this is a video on the area of quadrilaterals, and we define a quadrilateral as a shape with four sides, which is closed, has four angles, and a quadrilateral is a type of polygon. So I suppose the next question is, what is area? So area is the amount of space taken up by a two-dimensional shape or surface. Area is calculated by multiplying two lengths and has the units millimeters squared, centimeters squared, meters squared, or whatever the units are squared. So we've got some examples here, and we could count the squares. So for example, if I was to draw a shape like this, this makes it nice and easy to count squares. We've got 1 square, 2 squares, 3 squares, 4 squares. This shape would have an area of 4, and these are square centimeters squared. It's more difficult to count the squares here. So we have 2 squares there, we have half a square here, we have even less of a square here, a third. So this requires us to use some area formulas, and there's some really important area formulas on the right hand side. So we've got a parallelogram which has 2 pairs of parallel sides and 2 pairs of equal sides. We've got a trapezium where the condition is 1 set of parallel sides. We have a rhombus which has 2 sets of parallel sides and all sides are equal. And then we have a kite where we have 2 sets of equal sides. Now you may ask, what's the difference between a rhombus and a square? Well, a square has 4 right angles, and the angles in a rhombus are not right angles, but the opposite angles are equal. So if you want some more proofs about how we derive the formulas for these areas, you can click on this link here, and that will take you to one of my videos. So let's have a look at calculating some areas. Scroll down. Okay, so we've got some shapes here, and we will need to apply the area formulas. Underneath the shapes we have the answers. I'm just going to show you how to set out the workings for these questions. So let's identify the shapes. This is a parallelogram. This is a trapezium. This is a rhombus. Got another parallelogram. And you see if you can have a go at identifying these shapes. Now I'm just going to set out the correct workings for a parallelogram, a rhombus, trapezium, and a kite. So the first thing we do is we start off with the formulas. So let's do that then. Now you need to memorize these formulas. So the area of a parallelogram, let's do this here, a bit thicker. So we always start off with what we're trying to find. It could be a length, it could be an area, or it could be a volume. Here we're asked to find the area. So the area of a parallelogram is the base multiplied by the perpendicular height. It's a really common misconception. This is the perpendicular height, and this means 90-degree height. And we can do that for all of them. The rhombus, the area is the base times the height. The trapezium is half height, and the sum of the parallel sides. And my personal favourite, the kite, is half multiplied by the diagonal lengths. So let's work out the first one. We've got 8 times 4, which is 32 centimetres squared. That's for question 1. Let's do the rhombus, which is question 3. So we've got the base times the perpendicular height, which is 42 centimetres squared. For the trapezium, let's do question 5. We've got half the height, which is 2, and 9 plus 5. If we multiply those together, we get 14 centimetres squared. Now, if we had decimals, we need to add an appropriate degree of accuracy. And you need to refer to the question for that, whether it's the nearest whole number, 1 decimal places, 2 decimal places, or significant figures. Okay, the kite, which is question 6. Okay, so we've got one diagonal, which is 10. And the property of a kite is that these two sides are equal. A kite is made up of 2 congruent triangles, and congruent means identical. So half times 10 times 6, which gives 30 centimetres squared. Now you are good at doing this one, and see if you can get the correct answer. Okay, so hopefully you've done that now and you've got your correct answers. And we've got some questions here. Now, calculate the areas of these quadrilaterals using a structured vertical solution with the equal signs all lined up with the appropriate units. So pause the video and have a go at doing this question. Okay, so hopefully you've done that now. Let's use green. Okay, so we're defining what we're finding. The area is the base times the perpendicular height. So we've got 9 multiplied by 14. And we need to add our units. It's meters squared. And 14 times 9 is 126. So here we've got a kite. Let's do it down here. The area is half multiplied by the diagonals. So we've got half multiplied by 9 multiplied by 14. This time it's also meters squared. So half multiplied by 9 multiplied by 14 is 63. So this is a parallelogram. This is a trapezium, not a parallelogram. Okay, so we got half multiplied by the height, 10 plus 5, and let's move this out, times 11 times 15, and that gives us 137.5 centimeters squared, and we've given that to 1 decimal place. So just to reiterate, the answer includes two things: the units and the degree of accuracy. Which is given in the question. Okay, so let's have a look at some more complicated questions. Yikes. So we've got some quite difficult problems there, and I'm just going to give you a little example. So say, for instance, we have a square. It's not a very good square, and I'm going to call this 3 centimeters. So the properties of a square is that all the sides are equal, and that's what these lines mean. And I'm going to get a scissors, and I'm going to cut out another square of 1 centimeter. And I want you to find the area of the shaded region. So again, we're going to do a subtraction. We're going to have the big area multiplied by the small area. This is given a special name in maths. It's called the inclusion exclusion principle. So we're including everything, and then we're subtracting what we don't have. So the area of the big square is 3 squared. Forget the area of a square is length squared. And we're going to subtract the smaller area. So we get 9 subtract 1. So that gives us 8 centimeters squared. So when we calculate in the areas of shapes with shapes cut out, it's best to use the inclusion exclusion principle. So pause the video and have a go at these difficult questions. They're not easy, especially question C. And I want you to give your answers to 2 decimal places. So pause the video and give these your best effort. Okay, so let's have a look at the solutions. So let's use my favorite color, orange. Okay, so we're going to have the area is equal to the big minus the small for all of them. Area is equal to big minus small. And there's 2 ways you can do C, but we'll discuss that after we've done these 2. So the area of the big shape, it's a square, so that's just length squared. And the smaller shape is a kite, and that has an area half multiplied by the product of the diagonals. So this gives 20 squared minus, I'm going to use brackets. I think square brackets sometimes make the problem look a lot neater. And it's the full length of the diagonal. So we've got 24 multiplied by 10. Okay, so I hope you can all see that 20 squared is 400. And 10 times 24 is 240. Half it, we get 120. I can see a mistake. This should be 20, not 10. Okay, of course that was a test. So if we multiply this, we got half multiplied by 24 times 20, we get 240. And if we subtract that, we get 160, not forgetting our units, meters squared. Okay, so let's have a go at the second one. So we've got the big, which is L squared, multiplied by the small. The small is it looks like a rectangle. Well, let's add some dotted lines. This is actually a parallelogram. So we've got half the height A plus B. So we've got 15 squared minus half the height, which is 5, and multiplied by the sum of the sides, which is 15 plus 18.6. So on our calculators, we get 141 meters squared. And if you're doing a non-calculated test, they're likely to give you nicer and smaller numbers. So on question C, there's two ways we could do this. We could do inclusion, exclusion principle, or we could consider this a composite shape and split it up. Let's use a nicer colour. Not so thick. Green's nice. So we get two shapes there. Get this shape. And we get the shape. It would be good practice for you to use the composite shape method to see that you get the right answer. But I'm going to use the inclusion exclusion principle. So I think that's much easier. So if we use the inclusion exclusion principle, we are going to find the area of this, and then subtract what we don't have. I'm going to, you can cut this either way. I'm going to cut this here. Okay, so we have got two rectangles and we need to subtract two triangles. So the area is going to be the big subtracted from the small. Now these lines mean that the two sides are the same length. So we're going to get the big plus another big plus a small, subtract a small, and subtract another small. I'm going to change colour. Let's go with red. Okay, so we have got 1.2 multiplied the length of this is going to be 4.5 and we need to work out the area of this here. Well, if all this is 4.5, we don't know that it cuts it exactly in half. So we need to find the distance from here to here. And we are told that this is 1.2. And if all this is 4.5, we need to subtract 4.5 by 1.2, and that gives a distance of 3.3. So I'm just going to write down what we did there. 4.5 minus 1.2 gives 3.3. So we have got 1.2 multiplied by 3.3, and that is from length times length. Length times width for a rectangle. Now we've got this lovely rectangle, which is 4.5 multiplied by 1.2. This one's much easier. We need to subtract this triangle. Now the area of a triangle is half the height, which is 1.2, times the base. Now if we know this distance is 3.3 and this distance is 2, because these lines mean that the lengths are equal, we can subtract 3.3 by 2 to get 1.3. Let's work out the area of the second triangle. The height is 1.2. If we know that the total distance here is 4.5, so we need to work out this. If we know that total distance is 4.5, we need to subtract 1.2, and we also need to subtract 2. If we do that subtraction, we've got 4.5 minus 1.2 minus 2, and that gives us 1.3. So if we work that out on our calculators, we get 7.8 meters squared, and it says 2 decimal places, so we're going to get 8, 0. Okay, so hopefully you, just going to double check, see if you do get that. 1.2 times plus 4.5. It's really important to check your work, and that's what Mr. Winston is doing at the moment. 0.5 times 1.2 times 1.3, subtract 2.5 times 1.2 times 1.3. 7.80. Okay, so it's really important to check your work. Also to put your degree of accuracy, which is 2 decimal places. Okay, good luck with your revision, and the really important points for area are as follows. Let's always something else. So area, you must memorize the formulas. With your calculations, you must make sure you select correct lengths. You must make sure that the length in your formula corresponds to the appropriate length in the shape. Just to give an example, we've got a triangle and we've got the distances 2, 3, and let's go with 4. The 4 here is going to be the base, but we need the perpendicular height. These numbers will be used for calculating the perimeter. We haven't got the perpendicular height there. So for area calculation, it's formulas. Select the correct length, then units and degree of accuracy. Okay, so good luck with your maths, and look out for my next video, which is on surface area.